Looks like we're maxing out at about 11 viewers. So I'm going to just go ahead and get started, assuming people will be dropping in occasionally. So I just kind of want to first talk a little bit about the scope of this particular day. This was mostly, I was going to present to my lab about how I want our lab to work. And I was realizing that a lot of people are sort of talking about how to best integrate GitHub workflows into their sort of like lab management. And so I thought I would just stream it to other folks as well. And so the motivation here is to sort of like set up a workflow, but it presupposes that you have some familiarity with GitHub and R already. So I'm not really going to go into those. There's some links in the description to much better tools for doing that stuff. In particular, Jenny Bryan's Happy Git with R is how I learned how to do all this stuff. So I highly recommend just using that if you're starting from a more basic level. But we're going to talk a little bit more about like workflow and how I want work to be done in the lab. So we'll switch to sort of this view of my GitHub. And the first thing that I think is a really useful idea if you're managing a lab or managing an organization and you want to sort of increase the quality of the code that you publish is to set up an organization in GitHub. So we're all used to having our own personal accounts in GitHub. And those personal accounts are sort of where you're going to be starting a lot of your projects and working through your own individual code. But when you're running a lab or you're trying to publish code in an open access way, you kind of want a repository that holds the sort of like final version. And so when I started at CSU, I started this open ecological and hydrological data and analysis GitHub repo. And if you're at a university, these organizations can be free to add, and you can have infinite free private repositories and things like that. So my Google thing just said everyone dropped off, but I don't think that happened. So the first thing is to have an organization, and that really helps sort of make sure that when you release code, people know that that's the final publication version. So a good example of that is not from my lab, but my old lab in Tamlin Pavelski's lab, which is the Global Hydrology Lab. They have this repository where basically code that has been published now lives here. And so one of the papers I wrote as a postdoc lives in this Global Hydrology Lab repository, and this is the final version. And the nice thing is that I have a personal version that is sort of local, and that one is changing, and things are, updated more frequently on my local version, but they're not the final published version. So that's one reason to just have an organization. The other is you can sort of like control workflow more. So who's contributing and how they're contributing. So anyways, that's sort of like step one is getting an organization. Again, this video is not going to really cover that. I already have an organization. But I encourage you, if you're running a lab, to start an organization. You probably don't need one if you're working underneath someone on a project or something like that. So that's just once you have your organization running in a GitHub account, the first step to any project that I start is, even if any of my students are starting it, all my students have access to this repository, so they can also start repositories in here. I would just get into my organization, log into GitHub, and then I'll go to a new repository. And today we're going to be working on a analysis to sort of track water quality data upstream. So we're going to be using some NHD tools, which is just a way to sort of track streams and their connections to each other. And we're going to be joining that to some water quality portal data. So we'll just say this is water quality portal NHD joining. And you might want to add something in the description. This is a project to join data from the water quality portal to NHD flow lines and track watershed contributing area. And I'll make this public. I always like to add a README so that when you clone it, you have something that's actually going to show up on your computer. So then you just click Create Repository. So I like doing this description and this naming feature And then I'm just going to click Create Repository. And that'll take a second to sort of initiate. And then you get this README that just the title of the README is the title of the repository. And now if we go back to OpenEco Data Lab, we have this new repository that's been created here. And so the core idea with having an organization is that I'm not going to directly work in this folder because everything that comes into the organization should be code, analyses, etc. that has been reviewed by somebody else. So in this case, Bryce Pulver is going to join us in a bit, and he's going to help us sort of see how that workflow works. And so this sort of repository that we're starting from is I'm not going to work directly in it. Instead, we're going to use what's called the forking workflow. So what that means is I'm going to fork this main repository into my personal GitHub. And I do that by just going over here in the top right, and I click on fork. And I am a part of like way too many organizations, as you can see, but I can just go into my personal repository and fork it there. And what that does is it creates some isolation between my individual work and anybody else contributing to this. And it allows us to have a sort of explicit way that we contribute code to the workflow. And we're using the forking workflow because a lot of what we work on in our lab, we want anyone to be able to contribute to. So we leave it fairly open access so that someone else could fork this that has nothing to do with our lab and then contribute to it, submit a pull request, which you'll learn about in a second. And then I could include their improvements pretty easily. So I'll just fork it into my personal repo. And so it's just copying it because there's not much there. So it's just a very little data. And so now this is in my personal repository. And so this is the repository I want to work in directly. And so that's what we're going to do here. And we're just going to clone this repository. So we're going to take this link that's up here in the top right code. Many of you probably use HTTPS. Again, all of this is in Happy Git with R. Jenny Bryan shows how to use all these things, but I'm mostly focused on flow. So now I have this link to this repository, and so I'm just going to open our studio. And now I want to, maybe I want to start coding. So now that our studio is open, you go up here to File, and then I go New Project. And that always takes a second for some reason in this RStudio version. So we'll just sit here. It's a good time to remind you if you have questions so far, just throw them in the chat and I'll respond as soon as I can. Sometimes I feel like I have to do new project multiple times, but then it sometimes breaks too. Just be patient. It's taking longer than I was hoping. Can't really do anything until this happens. My clone, Tim, good question, was the SSH. And that's just because back in the day, SSH was sort of just easier to set up, but now HTTPS is a lot easier. And they're doing construction right outside of here. Huh, this is not working, of course. Yeah, I just saw your question. I think I answered it. There's enough of a lag that I'm confused. But yeah, SSH just used to be easier, and so I set it up for that, and I just never have changed it. HTTPS is very easy now. It used to be harder. I have not been on this computer in a long time, so maybe that's causing issues. just went back to do new project. Maybe it'll work better this time. Yay. Okay. So now I did file new project, act like the last 3 minutes didn't happen. And here we're using version control. So we're using Git, which is a way to do version control. So we're going to click on Git. And that thing I just copied is this repository. It can go into my papers folder, although it's not a paper. And so basically it's copying that. It's taking that name from the project that we already started in GitHub. And then there's this, it's just going into this subfolder. So I'm just going to create the project. And again, it should be fast because there's like hardly anything in there. And then you'll see now we're inside of this project. There's a couple of really nice features of working in a project. You can sort of always know where you are. So if you do like Git working directory over here, it's always going to, if you open a project, it's always going to start right at this location. So all the data should be sort of in the same place. So you don't have to do any like directory finding. And then now that I'm in here, maybe let's just write like a tiny bit of code and like we'll sort of just get going on that. As we do, you'll immediately see there's some choices that need to be made. So I like to set up my folders in this general way. So I'll have a folder that is my source folder. So that's where code goes. I always also like to have a data folder. And sometimes inside that data folder, it gets increasingly complex if it's a complex project. So I'll have like data, in, out, temp, things like that. But this is a small example, so I won't bother. And then I often have a docs folder, which will be like explainers, or if I knit HTMLs using our Markdown, I would put those knitted HTMLs in the documentation. And so I'm just making a new file here. I'm just going to say E. coli mapper, because what we're doing is taking data from the water quality portal, which is data on E. coli and streams, and we're trying to figure out what's the closest stream to each of these sites. And to do that, we'll need to load some packages, which I did not test before streaming because I'm on my work computer, which I haven't been on in a while, but I'm sure it'll work. So we're using SF, which is a spatial package. We'll use tidyverse, which is a package for tidying data. We'll use MapView, which is a package to just view spatial data, and we'll use NHD plus tools, which is a package to join stuff. Go away. I got to turn off Dropbox. If you get that error that I just got, it's because Dropbox and RStudio don't play nice. So I'm just going to turn off syncing for a while. And so I'm loading all these packages. The code here is not the main point. I just wanted to have at least something that's somewhat interesting. And then I just need to put the data in here. So we'll go to the WQP NHD joining folder. I'm going to open that up. And then my colleagues sent me this long site of E. coli data. And so that's just sitting here. And I just put it into this folder. And so just to make sure that we can actually access that data, you could do something like list files data. And we'll just see, oh, there's this E. coli sites.csv. Let's go ahead and read that CSV in. E. coli dat, read CSV data, E. coli sites.csv. And then, we can look at this a little bit by just printing it, and it just has basically cite and let long. So we're going to remove that first column, which I don't know what that is. So we'll just subtract it, and then we're going to convert this into a spatial object by just saying, hey, this is a spatial object, st as sf. The coordinates are c long then lat, because it's x then y. And the CRS I just know, which is the projection, is 4269. And we'll just reproject that into WGS84, which is 4263. So this is just now it's spatial data. We probably don't want to look at all 19,000 of those sites, so we'll just take a sample. we'll just take a random sample. Let's do sample frac. So that's sample of a fraction. So we'll just take like 1% of the data, and then we can use map view to just look where this data is. And it'll just pop up a little map here. It keeps this legend that's ridiculous, but again, that's not super important. And then now, you know, if we wanted to get the com ID, which is the way that this would map onto these NHD flow lines, which is a map of streams in the US, we can use this function called discover NHD plus ID. And this function can take some of the sub data, and it's a function that only works on one lat long at a time. So we just have to use the first one here, and then we'll get the com ID for that location. And so that's just going to be like where that site is according to NHD. And then we can use this com ID to track stuff in the NHD flow lines. And obviously to get all 19,000, we would want to either loop over this or map over this. So that's sort of like, let's say that's enough work to now say, I want to commit this. This is a version of the workflow that I feel like I'm confident in, and it's sort of done. So now in RStudio, I'm going to go over to this little Git icon. And now is when you'll start to see some stuff. So there's a thing called Git Ignore, which is really important. And I'll explain that in a second. You'll see there's this source folder. If I click on that, it'll then say, oh, inside the source folder is just one thing called E. coli mapper. And then inside of data, we're going to do something not really recommended for most projects, but this is such a small data set, it's okay. GitHub is not for data storage, and you can really mess up your GitHub repositories when you commit or send up large data. So anything above like a gigabyte or even really 500 megs, GitHub will yell at you and be like, why are you doing this? We're not data. If you want data, you have to ask for large file storage. And it can really sort of like be an annoying thing, as I've learned. And so in this case, though, we're going to actually submit it because it's a small data set. I think it's less than like 1 meg. And we're going to also commit our project, and then we're going to commit the Git Ignore. And so I'm going to go ahead and say commit on this, and it's going to pop this little window up. And then you have to submit a commit message. So I'll just say started linking WQP to com ID for NHD. It's not important that you understand the analysis I'm demoing. It's mostly just like, this is enough of a commitment of a commit message that I understand what this step was. So I'll hit commit, and that just locally is now saving a version of this code. And if I changed it, then I could go look at that old version or my new version. But to get it up on GitHub, we use this push. So we're going to go ahead and say push, and it's going to go back up to that GitHub remote, and that's where it should be now. And so that's sort of the full trajectory of like you work, you push, now your stuff's up locally. I talked about how it's dangerous to submit data. The way you would like not submit data is you could say, typically I would do something like data / and that's not going to commit anything in the data folder. I don't actually want to do that now because I do want to commit this data. And so that's sort of that's the full workflow. And then, you know, I just updated this. I think I just deleted one line, and you can just do that again. You can just commit message, deleted one line. This is an example of a commit that's far too narrow. It's not really anything all that new. And then you push it. So that's now pushed. And to confirm that it is, we'll go back up to our GitHub, and it doesn't look like anything's changed, but if I just refresh the page, now all this stuff is up here. And so that's sort of like now we've pushed it up to the my personal repository. But let's say, hey, I'm ready for the group to review this. I think Bryce is really going to like this code. Now I go into this button called pull requests. And so I'll do a new pull request. And this will just show all the changes I've made, which is not that much because it's a new project. And I just want to create a pull request. And what a pull request is essentially a review. So you're saying, hey, can someone check this out so that you can integrate it with a larger project and make sure it doesn't like have any fatal flaws, or that it doesn't overwrite work that Bryce has been doing on the side. So we can just go create pull request. started ComID merge. And then I can just say like, hey, Bryce. And I think I can actually add him. So it'll like send him an email. Oh, I guess I don't have his, he's not in my GitHub friends, I guess is how to say that. And so then that's fine though. And then I can just say, can you review and vectorize or something? Or just loop over the ComID finder. So then I create this pull request. And then so there's this little button called merge pull request. And basically the merge pull request is saying this is final, this is ready. On a project like this one, where like ultimately I'm going to be writing a lot of the code, I can go ahead and merge this pull request without Bryce's review. But you also usually want other people to be able to merge pull requests. So I'm going to actually just merge my own pull request here just to sort of like skip that step. And then we're going to switch over to Bryce's screen and show how he is going to then also copy this repository over, change some code, submit a pull request back to me, and I'll show you what it looks like when he changes some code for a pull request. So I'm going to just go ahead and merge this, and it was me who merged it. And so it'll track who has done what, and that's obviously useful if things sort of like break. So now we're just back in this, and now the OpenEco Data Lab version, the sort of final version, is all updated. So I think that's a good place to first ask, are there any questions that y'all want to have answered that you could put in the chat? The lag makes it extra hard to see if anybody has a question. I don't see any. Oh, Andrew Murray asked one. Yes, I'm initiating the pull request inside of my personal repository, the forked version. Exactly. And that's, again, to isolate it from sort of other code. I'm not working in this version of the way we're working on GitHub, you're never working directly on the main. You're always sort of using that as an excuse to really cleanly document and avoid any errors. So yeah, that's the logic, is to keep it isolated in your personal repository and then always do a pull request. And you know, if you're the one doing the merge on the pull request, that still has some value in my mind, because it's just like, I'm taking this step to put this in the sort of final version. But yeah, that's a great question. I think there's no other ones that have come up since Andrew asked, and we'll switch to Bryce's screen. Give me a second to sort of make sure that's working. And we should hear Bryce now.
Cool. Should be switched over. Let's see. Let's go over to presenting a entire screen. Screen one. Looks like it's loading. All right. Can you see that, Matt? All right. So, you know, we've been so let's say like there's some correspondence happening and we're going back and forth. And I got a notification from Matt saying that can you look over this code? Can you add some stuff to this? And so since our lab typically does the forked workflow, so I'll go to the Eco Lab giant huge repository database, and then go to the specific repository here. And since I don't have anything actually in my my repositories yet, so what I'm going to do is I'm just going to use the fork button right here. And we just want to make sure that it's going to my personal repositories. And so that'll take a second. Cool. So it looks like it's updated. And then it also lets you know that there is a merge request that Matt added a couple minutes ago. So you can always go back and you can look at pull requests and manage them. And these ones are going to show you open versus closed and tell you whether or not things are waiting for you. But let's go back to the code. So in order to do make sure that this is the exact same thing copied over again. So like before, we're just going to clone this, and then we're going to go back into RStudio, open new project. Don't save. We're going to go to version control. We want to go to Git. I want to make sure that's the specific URL that we just copied from our repository. And I guess it's fine if it goes in research. Sure. All right, so should be good to go. And then let's go to the source code, the eco mapper. Cool. So this is the code that Matt had just made a few minutes ago. So you could technically start working right now. And anything that you do when you make a when you push this code back up to your repository will save. But the thing now with working with a forked repository is that since it's totally isolated from everything else, something upstream may have happened. And if something upstream happens and you and it is approved and you try to make a push and then a pull request after that, you can actually override a lot of code, and it can cause a lot of problems and things can get messy. And then you have to go back and look through a lot of different iterations of your project. So really, really good practice is if you're working inside of a specific repository, you want to make sure that you pull that code. And if you so click on the version control. So there's a way to do it here with pull branches, or you can do it right here in the Git window by doing pull. But that only works if you're working with inside of the original master repository. And if you're not doing that, you need to make sure that you create a thing called a remote inside of the RStudio's Git. And so in order to do that, it's kind of a little bit verbose. So I always use this website. And I think that should be linked in the description. But basically it just tells you how to merge upstream repository changes. And so you would just want to follow these steps through. So we'll do that really quickly. Let's see if I can get these to be a little bit more visual. Okay, cool. So all this is doing is letting you know that you're in your own master. Um, so basically, this is saying like, okay, you don't have any remotes. So let's check and see what sort of folders there are in your like actual source and management of these different repositories. So Git remote. So basically, all we can see right here is that all I have, which makes sense, is just the origin. So we need to tell Git to go and add this remote to make an upstream repository that we're going to then pull from and make sure that it's updated. So the general way that you do this is right here. So let's do this. So copy. The terminal is really finicky, so you actually have to right click and paste. But you can. So then let's go grab that HTTPS again from the upstream one. So we know that it's the upstream one is forked right here. So we need to make sure that we're actually creating the remote from this one that's way upstream. So going over here into the code again, come on, drop down. So yeah, so we want to use the HTTPS copy, and then right here again, we're just going to want to paste. And so we're going to add that remote. And so that should have added that remote. And then what you're going to do right here is there's the next two steps are going to actually let you know whether or not your current repository's update to something upstream. So we're going to do git, not fit, git, git fetch. Cool. Yeah. So it looks like things should be up to date, and if they're not, we definitely can still merge, and it's always good safe practice to do that. So just git merge upstream master. So basically this is just telling you that this is something we can't merge because it's completely up to date, nothing has changed, which is totally fine. But as you can see here on the right, if there is stuff that has changed, it'll give you a huge list of plus or minuses of changes, and it'll update your repository. So let's do something. Let's add a little bit of stuff. So library praise. So all this library does is it just tells you you're doing a good job when you're coding. So now, let's see, did that run? Yep, that ran. And we'll just add praise. You're superb. Awesome. We just want to let Matt know that he did a great job on this section of code. So now that we've added this little bit of code, and we know that things are up to date, we can either, again, go through here, or we can go through the Git terminal. So now we're going to go commit. Let's see. Oh, it's not staged. That's interesting. Oh, it's probably because I didn't save it. Cool. Yep, that's why. I didn't save it. That's why. So now it should show up. And so now you just want to see right here in this window, it'll tell you exactly. So library praise, we're good. So you just want to make sure that you stage this and you click that you're staging this. Nice work. And we'll commit. Cool. So that committed, and then we will push it. Takes a minute. Cool. So that should be good to go. We'll close that out. This should be all ready to go. So we want to make sure that we're going back to our repositories. And then so we just want to go back here. And it looks like, yeah, it was my commit, my change was added about 25 seconds ago. Perfect. So now we want to just make sure that this goes back up to the upstream master. And this is where a pull request is really, really useful. So we just want to make a new pull request. And then this thing right here too, you saw it change. Git's really good at like making sure things are able to merge well. So if there's a big red X here, or if it's orange, that's when you would really want to start thinking about whether or not you pulled down the right version. But so this looks good. So we're just going to create the pull request. Added some praise. And then we're just going to create the pull request. And then it'll be sent over to anybody who's in charge of the master repository. Cool. And then so since I'm not actually a part of that repository as a contributor, I can't actually merge that pull request. There's no option for me to do that. So we'd have to switch it back over to Matt in order for that to be done. So this is probably a good spot for me to switch it back over to Matt.
Yeah, thanks, Bryce. That was super helpful. And so I'm back in the main repository now, and this will sort of be the final step that we're talking about these things directly. And, I look in this final repository, and I just can see there's a new pull request. So I can go into that pull request, and I can click on this nice work thing. And so I can sort of just, if I trust someone, I can just say merge pull request, or if I've talked to them about the code already. But the whole point of this is to sort of like slightly review the code. So we can go into the commit, and we can go actually look at what Bryce did. And then there's also this other way of looking at it that it just jumped to, where it says files changed. So only one file changed here. It's E. coli mapper. And Bryce just added like 2 lines of code. And that's sort of like all coming back to one spot. And Andrew, yes, that's a good question. So Andrew just asks, even though it's now been forked twice and it's in 3 different repositories, they are all being merged into a single repository for pull requests. And that's exactly right. So every pull request is sort of like updating the state of knowledge on this project. And a key to like obviously successful version of this workflow is that the person in charge, so if you were in my lab and you were doing like a project, you would be in charge of your own repository in addition to me. It wouldn't always just be me. But one of us is approving these changes as they come in, and updating that master a lot so that when a new person joins the lab and they want to work on that with you, or someone else wants to work on code from our lab, then if they work from the sort of Open Eco Data Lab main one, they're getting the most up-to-date code that has been also, it's like up-to-date plus quality. So yeah, that's a good question. And this all of the stuff we presented here is one way of working. And again, it's a little bit more focused on like outward facing code. There's another simpler way that would be the branching structure. And that's better for like teams that are mostly working just with each other. And that the code won't necessarily have contributions from outside users. But since the ideal here is that outside users eventually use and improve our code, that's why we're sort of using this forking repository. I think, now I can say, I just answered Andrew's question, but I can also sort of review it. And so I can say, thanks for the praise, looks great. And I can put that in there, and then I can also do line-by-line reviews. So I can say like, hey, this is a cool new package. And that would be a way for me to like give students feedback or be like, I think this is a bug, that's the wrong data, blah, blah, blah. And then I can just finish my review, and I can just approve it, which is to say like, this works, and I approve these changes. And then you could also say request change. So you could say like, that little code chunk you used is wrong, fix it. So now that I submitted the review, I can merge my pull requests. This thing has been reviewed and confirmed. We're all happy with its status. And then we'll go back up to the main repository. And now I have merged Bryce's comments, and they should have this library praise in here and the praise line. So that's sort of the like full version of this workflow that we're talking about. I know it's like fast, and we used a lot of terms that maybe are foreign to you, like fork, pull, all that stuff. But I just kind of wanted to walk through like what it looks like live, and then there's links in the description for how to really walk through this quite a bit slower for your own workflows. Are there questions that I can answer before I show just like a couple miscellaneous little tools that I like in GitHub? I'm not seeing any come up even with the lag. If they come up, feel free to ask them as I just wanted to show two other things that I really like. Again, with the mindset of like sort of managing workflows of a group. And so in our group, my ideal version of how we sort of like communicate progress and issues and stuff is actually in the GitHub, its repositories itself. And so I like to go to this repository, and then I go to this issues button. And so let's say like I want to do something in the future and it's just not working yet. So like earlier I mentioned that I want to loop over the water quality portal NHD join. And then I can just say like, I think a for loop will be fine, but we need to do the analysis for 1,000 sites, or really it's like 19,000 sites, not just one. So here I'm just identifying an issue, and this is like something that needs to be changed and improved. And so now if we go back to the main issues page, you can sort of keep track of a bunch of these, and they can be things that are broken or things that are future analysis. And it's just a really clean, easy way to track it. And it has this sort of like psychological value of like when you're done, you can go in and close the issue. So you can say, I've finished that. And linked with that is the last thing I'll show today, which is how to use GitHub Projects. I like this with a few of the projects I work on. This is how we manage communicating with the team. It sort of is like a partial replacement of, I guess, like Slack and other ways of communicating. So if you just click on projects, you can create a project. And so this will just be called, basically the project is essentially the folder. So I'm just going to call it the same thing. Tracking progress for this work. And I'm going to use a template here. And if you're familiar with a lot of like project tracking, there's the Kanban style, which is, you'll see in a second, it's basically like to do, working, done. And we'll use the automated Kanban style, which just puts issues directly into the to-do. So basically, this is just a way to say, like, future goals, and it uses Markdown documentation, so you can say like future goals, and then you can like set up a list of things. I think you make it like that. This is a checklist, and then I can add this in here, and oh, I failed. I think it's this. To make that check mark actually work, I think it needs to be like that, maybe. And if that doesn't work, I'll just give up. Ooh, it does. So, this is a checklist. And then basically as we're working on things in that checklist, we can sort of put it in the in progress, and then you can move it over into the done. And so this is just a nice way to communicate with your team without sending 1,000 emails about where we're at in the progress. I think those are the sort of main little goodies I wanted to talk about today. I really value feedback on this format. There's quite a few other things that I know that I want to share with our lab. And if people like this and find it useful, let me know in the chat, and I'll do this live stream thing again if it's not that useful. Also, I would like to know. So feel free to email me or let me know in the chat. The future topics I think would likely be something about how to integrate this sort of like open mindset with data, because again, GitHub can't handle large data sets. So we have like a Google Drive management workflow. And also I would walk through some more examples of how to troubleshoot Git and R, because when things get broken, they tend to get really broken. And it's just kind of useful sometimes to have something to go back to. So with that, I think it looks like people are dropping off. I don't think there's any questions. Yeah, let me know how everybody thought this went, and appreciate your time. I'll wait around for like 30 more seconds to see if any questions pop up. That's a good question, Andrew. Yeah, I mean, there's no real solve for, and you don't need to see my screen anymore. There's no real solve for that. So if people are working on the exact same lines of an analysis or something, you basically would want a different solution that you're all working on the same server. So that's going to be like a Google Docs for RStudio or whatever. I know RStudio is making something like that. Maybe it exists. And I know you can do that in RStudio Cloud in the next month or two. So there is that option. It's not quite this robust. One thing you can do is just communicate with the team. I haven't worked on any projects that are so large, like something like dplyr or something, where you would have multiple pull requests. And then that just requires, a manager of that to really understand and look through the code really carefully to see which ones take priority and which ones really work. That's a good question. I just use the RStudio and command line tools. I used GitHub Desktop when I first started, and I found it more confusing for some reason. And then just as I've been teaching more and more, I found that for most of my students, it's easiest to just use the stuff inside of RStudio. So yeah, great questions. And Bryce likes Git Kraken. Okay, I think with that, unless there's anything else, I'm going to end the stream. And we'll post some extra resources in the description later. We're going to develop this into a little bit more of like a full-blown course, not course, lesson. So we'll sort of edit this video and improve it. But yeah, thanks everybody. I really appreciate your time. Bye.